There is a date on the calendar that most people will pass through without noticing. The 4th of October 2026. A Sunday. A morning that will begin like most mornings begin. Alarm, coffee, the ordinary sequence of small human decisions that make up the texture of a day. The sun will rise at roughly the same time it rose the morning before. The news will carry the same categories of stories. Your neighborhood will look exactly as it did the day before, and the day before that. And yet on that specific night, if you step outside after dark and look toward the southeast, you will see a golden point of light sitting above the horizon that has been there for weeks and will be there for weeks more, but that on this particular night will be different in one specific, measurable, physical way that it has not been different since September 2024 and will not be different again until October 2027. On the 4th of October 2026, Saturn reaches opposition. It will be at its closest point to Earth for the entire year. It will be at its brightest. It will rise at sunset and be visible all night, higher in the sky than at any other point in 2026. And it will be, if you have even a modest telescope, the single most overwhelming visual experience available to any human being looking up from the surface of this planet. Not because opposition is rare. Saturn reaches opposition roughly every year. Not because this particular opposition is the most dramatic in history. The rings will be tilted at only 7.5 degrees toward Earth, less open than they were a decade ago. No. What makes the 4th of October, 2026 different? What makes it the specific night that everything shifts is what happened in the 18 months before it. In March of 2025, Saturn's rings disappeared. Not metaphorically, not approximately. They actually disappeared, for the first time in 16 years, edge-on to Earth, so thin that they could not be seen in any but the most powerful telescopes on the planet. And Saturn, which every astronomy photograph and every first-time telescope experience has shown as ringed, glorious, unmistakably itself, Saturn briefly became a plain yellow sphere, a ball, an unremarkable gas giant indistinguishable from any other. And then the rings began to come back. They are coming back right now. October 4th is the night you will see them returning. The first opposition since the rings nearly vanished. The first close approach since Saturn was ringless. The beginning of a 6-year journey toward the most spectacular view of this planet any living human being will have experienced. This video exists because most people will let October 4th pass without knowing what they are looking at, without knowing what just ended, what is just beginning, and why the particular moment they happen to glance up at a golden star in the southern sky is the moment that the greatest visual story in our solar system started a new chapter. After you watch this, you cannot unsee what you will know. Let us begin. Before we get started, if you love exploring the depths of space as much as we do, take a second to like this video and subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now, let's begin. Before October 4th makes any sense, you need to understand what happened in March 2025. And to understand what happened in March 2025, you need to understand a geometry problem that has fascinated human beings since the invention of the telescope, and that baffled one of the greatest minds in the history of science so completely that he publicly declared he did not. I know what to say. The year was 1610. Galileo Galilei turned his telescope toward the brightest star he could find in the summer sky, a golden, steady, non-twinkling point that ancient observers had called the Wanderer, the slowest of the 5 naked-eye planets, the one that seemed to move with the patience of something ancient and deliberate. What he saw through his lens stopped him. Saturn had ears. Not rings. He did not know what rings were. In this context, he did not have a framework for a planet with a disk of material orbiting it. What his 30-power telescope revealed were 2 lateral protrusions, one on each side of the planet's disk, symmetrical, attached, unlike anything he had ever seen in the sky. He wrote to his patron describing what he had found, describing it in the most peculiar circumlocutions, eventually encoding it in an anagram to establish priority without revealing his discovery. Smeas murmel mipo taleumi buna nugtaras, a scramble of the Latin phrase that translated decoded to I have observed the highest planet to be tripartite in form. Tripartite. 3-part. a central globe with two attached lobes. 2 years later, in 1612, Galileo turned his telescope towards Saturn again. The ears were gone. The planet was smooth, unadorned, a perfect sphere with nothing attached, nothing protruding, no feature to distinguish it from Jupiter or any other gas giant. He wrote what is possibly the most famous expression of astronomical bewilderment in history. I do not know what to say in a case so surprising, so unlooked for, and so novel. He did not know what to say because he did not know what he was looking at. He did not know that what he had seen in 1610 was the rings of Saturn, magnificently tilted toward Earth, presenting their upper face to his telescope and showing their full width across nearly 45 degrees of tilt. He did not know that what he saw in 1612 was those same rings, edge-on, invisibly thin, hidden by their own geometry. He did not know, because the concept of a planetary ring system did not exist. It would be another 45 years before the Dutch astronomer Christiaan Huygens, using a better telescope and a better theory, explained what Galileo had seen. The ears were a ring, a single, flat, continuous ring circling Saturn's equator, tilted relative to the Earth's orbital plane, appearing wide and open when Earth was above or below the ring plane, appearing thin and invisible when Earth was in the plane of the ring itself. What happened to Galileo in 1612 happened to the world in March 2025. The difference is that we knew it was happening. We had 400 years of accumulated understanding. We knew about the ring plane crossing. We knew the precise mechanism. We knew the exact date, the 23rd of March, 2025, 12:04 p.m., UTC, with a precision that Galileo could not have conceived. We knew exactly what was happening and why. And yet, most people still missed it. Not because they lacked access to the information was everywhere. In every amateur astronomy publication, every planetarium newsletter, every sky-watching website and app. They missed it because knowing something is going to happen and actually going outside to look are two different acts, requiring two different kinds of intention. The rings disappeared. Let us understand the geometry precisely, because the geometry is where the beauty lives. Saturn's axis of rotation is tilted at 26.7 degrees relative to its orbital plane, roughly the same tilt as Earth's axis, 23.5 degrees, which gives us our seasons. As Saturn makes its 4-year journey around the Sun, the direction of this tilt remains roughly fixed in space. Earth, meanwhile, orbits the Sun in a plane that is slightly different from Saturn's orbital plane. The combination of these two slightly misaligned orbits, viewed across the changing geometry as both planets move, means that our perspective on Saturn's rings shifts continuously across a 4-year cycle. Sometimes we see the rings from steeply above. Think of looking down at a vinyl record from a steeply inclined angle, the full width of the surface visible, the grooves distinct, the geometry clear. In 2017, Saturn's rings were tilted at their maximum toward Earth, 27 degrees, and every telescope pointed at them showed the full, glorious, edge-to-edge spectacle of the ring system at its most open. From 2017 onward, the tilt has been decreasing. Year by year, degree by degree, the rings have been turning edge-on. From 27 degrees in 2017, to 20 degrees in 2019, to 15 degrees in 2021, to 9 degrees in 2023, to 5 degrees in early 2024, to the minimum in March 2025. The minimum occurred on the 23rd of March 2025 at exactly 12:04 p.m. UTC. At that moment, the Earth passed through the plane of Saturn's rings, the precise geometric moment at which the rings are truly mathematically edge-on. Their thickness, which can be as little as 10 meters in some sections and rarely exceeds a kilometer anywhere, is invisible from Earth at this orientation. The rings span 273,000 kilometers across but are too thin to see edge-on from 1.3 billion kilometers away. Saturn, at this moment, was ringless as seen from Earth. But there was a catch, a cruel joke of orbital timing that the universe served without apology. The 23rd of March 2025 was 11 days after Saturn had passed behind the Sun from Earth's perspective. Solar conjunction, the moment when Saturn and the Sun share the same direction in our sky. making Saturn completely unobservable for weeks. Saturn was too close to the Sun's glare to be seen from Earth during the ring plane crossing. Virtually no one could observe it. The telescopes that might have captured Saturn's ringless disk were pointed away from the Sun, as they always must be. The most dramatic geometric event in Saturn's 1.5-year ring cycle, and most of humanity missed it. But the rings did not bounce back immediately. They returned slowly, by fractions of a degree per month, emerging from the Sun's glare in late April of 2025, with the most minimal tilt anyone had seen in 16 years, barely a line. Barely visible, barely there. And then came November 2025. Earth and Saturn's geometry conspired again. The ring tilt, which had been increasing very slowly since the March crossing, reached a second minimum. On the 23rd of November, 2025, the rings were once again at their thinnest viewing angle, 0.4 degrees, less than half a degree. The rings were essentially edge-on again, but this time Saturn was not hidden by the Sunday. This time it was in the evening sky, observable, accessible to anyone with a telescope. This was the second chance to see Saturn ringless, and virtually no one knew it was happening. Here is what seeing Saturn without its rings actually looks like through a telescope. You point your instrument at the bright golden star in the southern sky. You focus. Saturn resolves from a point of light into a disk, a flat, yellowish circle, slightly ablate at the poles. And that is all. No rings, no extensions, no graceful sweeping arcs, no hat brim, no halo. Just a banded sphere with subtle yellow-brown cloud belts and, if you look carefully with a larger telescope, the faint trace of a nearly invisible line, exactly through the planet's equator, the edge of the ring system, seen from exactly the side, visible only because the outer rings catch enough light to cast the thinnest possible shadow line. Strung alongside this bare sphere, the moons. Without the rings to dominate the visual field, Titan and its siblings suddenly become more prominent. They line up in a precise row, extending from either side of the planet east and west, like a ruled line drawn by someone with extraordinary precision. Titan, usually the most obvious, glowing amber at magnitude 8.9, Rhea closer in, Dione and Tethys inside that. All of them in the same plane as the invisible rings, extending outward from the bare disk of the planet like a string of perfectly spaced beads. It is beautiful, it is Saturn, but it is not the Saturn that every astronomy book, every telescope advertisement, every iconic NASA photograph has shown you. It is a different planet. A stripped down, unexpectedly vulnerable planet. A planet that looks, through a telescope, almost exactly like Jupiter, the same swirling cloud bands, the same oblate disk, the same family of moon points extending from the equatorial plane, stripped of the one feature that makes it instantly, unmistakably, incomparably itself. This is what Galileo saw in 1612. This is what baffled him so completely, he wrote, that he could not understand what he was seeing. He was right to be baffled. Saturn without its rings is philosophically disorienting, in a way that Saturn with its rings never is. Because Saturn with its rings confirms your expectations. You have seen the photographs, you have seen the diagrams, you know about the rings. When you look through the eyepiece and see the rings, you feel the satisfaction of the world confirming what you knew. The universe is doing exactly what you were told it would do. Saturn without its rings does something more unsettling. It reminds you that what you were told was not complete, that the images in the textbooks were taken from a specific perspective at a specific moment in a 2-9-year cycle, at a moment when the rings happened to be tilted open. It reminds you that what we call Saturn in everyday understanding is not really Saturn. It is a specific, perspective-dependent, time-dependent view of Saturn, and that Saturn itself, the planet, independent of how we happen to be seeing it, is something more complex, more variable, more mysterious than the iconic image admits. That is what November 2025 offered. A brief window in which anyone with a small telescope could look at Saturn and see it without its defining feature, and in so doing, understand something about the nature of perception and completeness, an astronomical truth that no textbook photograph can teach. Most people missed it. The 4th of October 2026 is the correction. Between the 23rd of November, 2025, and the 4th of October, 2026, the rings have been returning. Not dramatically, not in a way visible from night to night or even from week to week. The ring tilt increases by roughly 1 degree per month. In December 2025, the rings were just barely visible, a faint extension on either side of Saturn's disk, detectable only in larger telescopes under good seeing conditions. In January 2026, slightly more open. In February, more. By April, recognizably there, definitely rings, but thin. By July, tilted enough to show the rings clearly as a distinct structure. By October 4th, when Saturn reaches opposition, 7.5 degrees. 7.5 degrees of tilt. This does not sound like much. For reference, the maximum tilt of 27 degrees was achieved in 2017, and the view then was spectacular. The full ring system displayed like a vinyl record, tilted generously toward you. The Cassini division visible in even modest telescopes, the A, B, and C rings clearly distinguishable, the entire architecture of the system on display. 7.5 degrees is not that, but 7.5 degrees is not edge-on either, and after the experience of edge-on after months of a ringless Saturn, after the bafflement of seeing the bare disk 7.5 degrees of returning ring tilt is experienced very differently than 7.5 degrees would be experienced by someone who had never seen the rings at all. When you have watched the rings nearly vanish, and then watched them begin to return, and then stand at a telescope on the night of October 4th and see them there, not fully open, but open, recognizably open, present in a way that they were not. A year ago you are not seeing 7.5 degrees of ring tilt. You are seeing the rings come back to life. You are participating in a story that began when Galileo scratched his head in 1612 and wrote that he did not know what to say. You are watching Saturn become itself again, and you will never see it the same way afterward. Now let us talk about what you are actually seeing when you see those rings. Because most people who have pointed a telescope at Saturn and gasped at the view have never been told the complete truth about what they are looking at. The rings are not solid. This is the first thing. Everything about the way they look suggests solidity. They are flat, thin, precisely defined, geometrically perfect in their proportions. They catch the sunlight and reflect it back with a uniform, consistent brightness. They look, in every visual sense, like solid plates, like a disk of material orbiting the planet the way a vinyl record sits on a turntable, rigid and continuous. They are not. The ring system of Saturn is composed of billions, possibly trillions of individual particles of water ice and rocky debris, each one following its own independent orbit around Saturn, each one moving at its own velocity determined by its distance from the planet. The innermost particles are moving faster, the outermost more slowly, exactly as all orbiting bodies must. There is no physical connection between one particle and the next. No material holds them in a solid sheet. No force except gravity, and the collective self-gravity of the ring material keeps them from dispersing. What you are seeing when you look at the rings is not a disk, it is a swarm, a coordinated, gravitationally organized swarm of particles so numerous and so densely packed that from a distance of 1.3 billion kilometers, their individual nature is completely invisible, and they appear to your eye as a continuous, solid, brilliantly reflective surface. The individual ring particles range in size from grains of fine sand to boulders the size of houses, most a small pebble to boulder size, a few centimeters to a few meters across. They are made primarily of water ice, which is why the rings appear so bright and white when fully illuminated. Some are pure ice. Others are ice with rock or organic material mixed in, producing subtle color variations across the ring system that can be detected in high-resolution photographs but are invisible to the eye through any amateur telescope. The rings are also thin in a way that defies easy comparison. The ring system spans 273,000 kilometers from the inner D ring to the outer F ring. For reference, Earth is 12,742 kilometers in diameter. The rings extend across a distance 20 times the diameter of Earth, and their thickness, the extent of the ring material above and below the ring plane, varies between 10 meters and 1 kilometer, depending on location within the system. 10 meters, in a structure 273,000 kilometers across. This is the equivalent of a sheet of paper 1 millimeter thick stretching across a football field. If you scaled the ring system so that its diameter was the width of a football field 100 meters, the rings would be less than 4 micrometers thick, thinner than a human hair, thinner than a single cell, the flattest, thinnest macroscopic structure in the solar system, hanging in space around a planet 116,000 kilometers wide. This is why they disappear. Not because they become invisible when edge-on in some approximate sense. They become invisible because they are, in any realistic physical sense, edge-on. There is almost nothing there. You are looking at the edge of a structure that is 10 meters to 1 kilometer thick from a distance of 1.3 billion kilometers. Of course you cannot see it. Of course Galileo was baffled. The rings are also young, cosmically young, disturbingly young. This is one of the most uncomfortable facts in planetary science, and it tends to be buried in the fine print of any account of Saturn's ring system, because it raises a question that, once raised, demands an answer we do not have. For most of the history of planetary science, it was assumed that Saturn's rings were ancient, primordial, formed at the same time as the planet, 4.5 billion years ago, from the material of the protoplanetary disk that also produced the planet itself. This assumption was comfortable because it meant the rings had always been there, had been there throughout Earth's geological history, throughout the evolution of life on this planet, throughout all human history. The Saturn we see is the Saturn that has always been. This assumption is wrong. The Cassini spacecraft, which orbited Saturn from 2004 to 2017 and provided the most detailed dataset ever assembled on any planet other than Earth, returned measurements of the ring system's mass and composition that, when interpreted carefully, pointed to an uncomfortable conclusion. The rings are not ancient. They are, in cosmological terms, recent. The most widely accepted estimate from Cassini data, published in multiple peer-reviewed papers from 2019 onward, places the age of the main ring system at approximately 10 to 100 million years. Some estimates go as low as 10 million years, a few go higher, to several hundred million years, but the preponderance of evidence points to a ring system that formed well after the solar system did, well after Earth formed, well after complex life appeared, possibly as recently as the age of the dinosaurs. The rings of Saturn, the feature that defines the most visually iconic object in the solar system, the feature that made Galileo write in bafflement, the feature that has captured the imagination of every human being who has ever pointed a telescope at the night sky, possibly formed while non-avian dinosaurs were still alive on Earth. While Tyrannosaurus rex was still hunting in what would become Montana, while Triceratops was grazing in what would become Wyoming, while the Cretaceous period was entering its final stages before the asteroid impact that ended the age of large reptiles. 10 million years is the low estimate. The Cretaceous ended 66 million years ago. If the lower estimates are correct, the rings formed after the dinosaurs were gone. Think about what this means. The most beautiful thing visible from Earth's surface in any amateur telescope, the object that has produced more first-time stargazers, more involuntary gasps of wonder, more converts to astronomy than any other observation available, with modest equipment did not exist when the first mammals were evolving, may not have existed when the first hominids appeared, possibly formed while our own genus, Homo, was already walking the African savanna. How? The leading theory is a murder. As it usually is with beautiful things in the solar system, the hypothesized sequence goes like this: a large moon comparable in size to Titan, Saturn's largest current moon, which is larger than the planet Mercury orbited Saturn in the distant past. This moon's orbit was perturbed by some gravitational interaction we have not yet precisely identified, inward toward the planet. As the moon's orbit decayed, and it approached closer and closer to Saturn, it crossed a threshold, the Roche limit, the distance at which Saturn's tidal forces exceeded the internal gravitational force holding the moon together. The moon began to disintegrate, not in a single catastrophic instant over thousands of years. The tidal forces slowly, relentlessly pulled the moon apart. The outer, icy layers most moons are differentiated, with rocky cores and icy mantles, were stripped first. The ice was shredded, scattered into Saturn's orbital plane, and began the process of spreading, colliding, fragmenting, and distributing itself into the flat ring structure we observe today. The rocky core, freed from its icy mantle, continued to spiral inward and was eventually consumed by the planet. The beautiful rings we admire tonight or will admire on October 4th are, in this model, the scattered remains of a world. Not just debris, not just rock and ice. The demolished remnants of a moon that once had a surface, once had topography, once completed its own orbit around Saturn with the kind of gravitational dignity that all moons deserve. The rings are a graveyard. A very young, very thin, very beautiful graveyard. And they will not last. The rings are dying. Cassini confirmed it. The data is unambiguous. The process has a name. Ring rain. The ring particles, ice crystals, pebbles, grains of frozen water are not static. They interact with Saturn's magnetic field and with the planet's upper atmosphere through a complex electromagnetic process that is still being studied. The magnetic field ionizes some of the ring material, particularly the smallest grains, and these ionized particles are funneled along the magnetic field lines down into Saturn's atmosphere at the magnetic poles. They fall as rain. Ice rain. Material that was a ring particle a moment ago falls into Saturn and ceases to be a ring particle forever. Cassini measured this ring rain at rates that were staggering. The estimate from the Cassini data, Saturn is losing between 432 and 2,870 kilograms of ring material per second to ring rain. Per second. Even at the lower estimate, this is roughly 40 metric tons per minute, more than 50,000 metric tons per day, more than 18 million metric tons per year. This sounds like an enormous amount of mass to be losing, until you consider that the ring system's total mass is estimated at approximately 1.5, 4 times 10, 19 kilograms, roughly 0.4 times the mass of Mimas, Saturn's innermost named moon. That is an enormous amount of ice, but when you divide the total mass by the ring rain rate, the lifespan of the ring system comes out to somewhere between 100 million and 300 million years. The rings will be gone in 100 to 300 million years. 100 million years. Earth's geological history goes back 4.5 billion years. 100 million years ago, flowering plants were just appearing. Dinosaurs were everywhere. The Atlantic Ocean was narrower. Africa and South America had recently separated. The continents would be recognizable, but the world would be profoundly different. In 100 million years, if the lower ring rain estimates are correct, the Saturn that any civilization then existing on Earth points a telescope at will have no rings to show. It will be a bare yellow sphere, a gas giant like any other, an unremarkable member of the outer solar system with no visual feature that would make a first-time observer gasp. We are living at the brief, cosmically improbable moment when Saturn has rings. They formed, at most, a few 100 million years ago. They will vanish in 100 to 300 million years more. In the 4-5 billion year history of the solar system, the rings are present for a window of perhaps 400 to 500 million years, roughly 10% of the solar system's total age. If an intelligent civilization had emerged on Earth 1 billion years earlier, they would have had no rings to observe. If another emerges 1 billion years from now, the same. We are the civilization that happens to exist when the rings are there. We are lucky in a way that is difficult to fully feel on any ordinary night. October 4th is not an ordinary night. But before we get to Cassini, let us talk about Saturn itself, not the rings, but the planet that the rings encircle. Because the rings are what stops your eye, but the planet is what rewards your sustained attention. Saturn is a gas giant. Technically, a hydrogen-helium sphere, approximately 75% hydrogen and 25% helium by mass, with trace amounts of methane, ammonia, water and heavier elements. It has no solid surface. There is no ground on Saturn. The atmosphere transitions gradually from the gas you can see at the cloud tops, the yellow-tan banded atmosphere visible through even a small telescope, to increasingly pressurized. Increasingly hot fluid as you descend. Somewhere deep inside Saturn, the pressure becomes high enough that the hydrogen transitions into a metallic state, a fluid that conducts electricity as easily as copper does. This metallic hydrogen layer is believed to be the source of Saturn's powerful magnetic field the third strongest in the solar system after Jupiter and the Sunday. Saturn is the least dense planet in the solar system. Its mean density is approximately 0.687 grams per cubic centimetre. This is less than the density of water, which is 1 grams per cubic centimetre. This fact is usually presented as the remarkable party trick it is. If you could find a bathtub large enough, a bathtub roughly 120,000 kilometres across, Saturn would float in it. This is not just a curiosity, it tells you something profound about what the planet is made of. Saturn is not a small rock wrapped in gas. It is a vast sphere of gas with a relatively small, rocky and metallic core at its centre, a core estimated to be somewhere between 10 and 20 times the mass of Earth, but surrounded by a planet that is 95 times Earth's total mass. The gas is the planet. The core is the seed around which the gas coalesced when the solar system formed. But what you are looking at when you look at Saturn is overwhelmingly hydrogen and helium. This hydrogen and helium was here before Earth formed, before the solar system finished assembling. When the sun ignited and the solar wind began blowing, the gas from the inner solar system clearing the terrestrial planet zone of the light elements that would have made Earth a gas giant rather than a rock, the outer solar system retained its primordial inventory. Jupiter and Saturn are, in a real sense, the leftover raw material of stellar formation. They are what the Sun would have looked like if it had been slightly smaller, if the mass had been insufficient to ignite fusion. They are failed stars. Not contemptible failures, glorious failures, bodies of extraordinary complexity and beauty and violence, but failures in the technical sense that their central temperatures and pressures never reach the threshold for nuclear fusion. Saturn generates its own heat, not through fusion, through gravitational compression. As the planet slowly contracts over geological time under its own gravity, the inward motion converts gravitational potential energy into thermal energy. Saturn radiates into space about 2.3 times more energy than it receives from the Sunday. The excess is internal heat leaking outward from the slow compression of the planet's interior. The cloud bands you see through a telescope are the visible expression of this internal heat energy. Hot gas rising from depth, carrying heat toward the surface, spreading laterally at the level where the temperature and pressure allow cloud condensation, then cooling and descending again. This convective circulation rising hot material, spreading, cooling, descending, creates the alternating light and dark bands that are the most obvious feature of Saturn's visible disk. The light zones are where gas is rising, the dark belts are where gas is descending. The pattern is maintained by the planet's rapid rotation. Saturn rotates once every 10.7 hours, the second fastest rotational period of any planet after Jupiter, which stretches the convective cells into horizontal bands through the Coriolis effect. Spin a fluid fast enough, and the circulation pattern is forced to align with the spin axis, creating the banded structure. Saturn's rotation is so fast that it distorts the planet's shape. Saturn is the most oblate planet in the solar system, meaning the most noticeably non-spherical. Its equatorial diameter is 116,460 kilometers. Its polar diameter is 107,580 kilometers. The difference is 8,880 kilometers, about 70% of Earth's diameter. Saturn's poles are flattened noticeably compared to its equator. You can see this in a telescope on a good night. The disk of Saturn is not a circle. It is visibly, measurably wider across the equator than it is from pole to pole. This oblateness, combined with the ring system tilted at 7.5 degrees, creates one of the most geometrically interesting views in the solar system. An oblate golden disk surrounded by thin ellipses of ice, the shadow of the globe falling across the inner rings in a curved crescent, the shadow of the rings falling across the globe in a dark arc. The three-dimensional geometry of the system is readable in the shadows. Look for the shadow of the rings on the globe. On October 4th, slightly off opposition geometry means the shadow will be visible, a curved dark band across Saturn's northern hemisphere, where the rings block the sunlight from reaching the cloud surface below. This shadow was the first clue that the rings and the planet existed in three-dimensional space, rather than as flat disks, the shadow being geometrically impossible. If the rings were actually attached to the planet's surface, the shadow tells you the rings float. It tells you that the rings are not features of Saturn's surface, not extensions of the atmosphere or the cloud bands, but independent structures, separated from the planet by tens of thousands of kilometers of empty space, existing at their own distances, following their own orbital paths, intersecting our line of sight in a way that creates the visual impression of a continuous attached disk. The shadow disproves that impression in a single observation. The rings float. There is space between them and the planet, emptiness. And that emptiness is what makes them rings rather than bands of atmosphere. Let us also talk about what Cassini did, because any story about Saturn in 2026 that does not include Cassini is incomplete in a way that the mission earned the right to prevent. The Cassini spacecraft was launched on the 15th of October, 1997. It carried the Huygens probe, built by the European Space Agency, which would eventually be released to descend through the atmosphere of Titan. It was a joint mission between NASA, ESA, and the Italian Space Agency, the product of an international collaboration that spent decades designing and building a spacecraft to orbit Saturn and study it in comprehensive detail. It arrived at Saturn on the 1st of July 2004. It fired its main engine for 96 minutes to slow down enough to be captured by Saturn's gravity. It became the first spacecraft ever to orbit Saturn. For the next 13 years, Cassini orbited Saturn. It made 293 orbits. It flew by Titan 127 times. It flew by Enceladus 23 times. It photographed every ring, every moon, every storm, every shadow cast by every moon onto every ring. It discovered the geysers of Enceladus. It mapped the methane lakes of Titan. It found the hexagonal polar storm. It detected the ring rain. It measured the age of the rings. It photographed the far side of the moon. It took the famous pale blue dot image, updated the image called The Day the Earth Smiled, in which Earth appears as a tiny blue dot in the gap between Saturn's ring arms, and every human being who has ever lived appears in a single pixel. 13 years of science. More data about a single planet than any mission in history had returned before. A dataset that planetary scientists are still mining in 2026, still finding new discoveries in, still publishing papers about. Cassini changed our understanding of the Saturnian system so completely that the pre-Cassini and post-Cassini understanding of Saturn might as well be the understanding of two different objects. And then, in September 2017, the fuel was nearly gone. The decision that NASA made at this point is one of the most moving acts of scientific responsibility in the history of space exploration. Cassini could not simply be left adrift. A spacecraft with residual microbial contamination from Earth, orbiting Saturn indefinitely, might eventually crash into Enceladus or Titan moons that we now know to have subsurface oceans, moons that represent some of the most promising locations for extraterrestrial life in the solar system. Contaminating those moons with Earth biology would compromise every future scientific investigation of their potential for life. So Cassini was directed into Saturn. On the 15th of September 2017, Cassini fired its thrusters and changed its orbit, sending it on a path that would terminate in Saturn's atmosphere. In its final orbits, the grand finale series, 22 orbits diving between Saturn and its innermost rings, flying closer to Saturn than any spacecraft had ever been, it returned unprecedented data. Images from inside the ring system, measurements of the ring mass, direct sampling of the ring rain material, the closest views of Saturn's cloud tops ever obtained. Then, on the 15th of September 2017, at 7:55 a.m. Eastern Time, Cassini entered Saturn's atmosphere and was destroyed. It fought to keep its antenna pointed at Earth throughout its final descent, transmitting data until the last possible moment before the aerodynamic forces overwhelmed its attitude control. It returned data for 91 seconds after it entered the atmosphere. Then the signal stopped. The spacecraft that had given us more knowledge about Saturn than all the centuries of observation before it, that had been our eyes and ears at Saturn for 13 years, that had flown 7.9 billion kilometers to be there, it melted. It vaporized. Its atoms mixed with Saturn's atmosphere and it ceased to exist as Cassini and became part of the planet it had spent its working life studying. The team in Mission Control, watching the telemetry flatline, did not cheer. They wept. This is worth sitting with on the 4th of October 2026. When you look at Saturn through a telescope on that night, or even with your naked eye, That steady golden point rising in the southeast, you are looking at a planet whose most intimate secrets were unlocked by a machine that chose to die rather than contaminate the worlds it discovered. A machine that our species built, aimed at the right target, and ran for 13 years past its intended lifespan, returning science we are still learning from. Cassini changed how we see Saturn. October 4th is an occasion to look at what Cassini left us with. Before the experience section, let us also properly introduce Saturn's extraordinary system of moons. Because on October 4th, you are not looking at a planet in isolation. You are looking at a planetary system, a mini-solar system, with dozens of active worlds, each one remarkable in its own right. Each one contributing something specific to the visual and scientific landscape of what you observe. Saturn has at least 274 confirmed moons with measured orbits. This is more than any other planet in the solar system. They range from Titan, 5,150 kilometers in diameter, larger than the planet Mercury, to tiny irregular captured asteroids barely a kilometer across, barely held in orbit by Saturn's gravity, likely primordial interlopers from the outer solar system, dragged into captivity by gravitational braking. The moons visible through amateur telescopes on October 4th are the bright inner moons. Let us meet them. Titan magnitude 8.9, visible in any telescope that resolves the rings. It orbits Saturn every 15.9 days, at a distance of 1,221,870 kilometers. On October 4th, it will be somewhere within a few ring widths of Saturn, possibly to the east, possibly to the west. Depending on where in its orbit it falls on that specific night, your planetarium software will tell you exactly. Titan is unique among all moons in the solar system in having a thick, dense atmosphere. Atmospheric pressure at Titan's surface is 1.45 times Earth's atmospheric pressure, heavier than our air. The atmosphere is primarily nitrogen, 95%, and methane, 5%, with a complex organic chemistry in the upper atmosphere that produces the orange haze that gives Titan its distinctive amber color. Below the haze, lakes. Not water lakes, liquid methane and ethane, at temperatures around negative 179 degrees Celsius. The largest, Kraken Mare, is larger than the Caspian Sea. The equatorial dunes are made of organic particles, electrostatically charged, piled up by a methane wind into ridges hundreds of meters high. The rivers that carved the channels visible in Cassini radar images flowed with liquid methane. The dot of light near Saturn on October 4th is all of this. Rhea magnitude 9.7, visible in 100 mm and larger telescopes under good conditions. Second largest moon of Saturn, heavily cratered, icy, geologically dead by any standard. A world that has been slowly accumulating impact craters since the early solar system without anything to erase them. Its surface is one of the oldest in the Saturnian system, a record of 4.5 billion years of bombardment preserved in ice. Dione magnitude 10.4, slightly smaller than Rhea. Notable for having wispy terrain bright, streaky patterns across its icy surface that Cassini imaging revealed to be networks of ice cliffs, scarps formed by tectonic fracturing of the icy crust. A world that was once internally active enough to crack its own surface from within. Tethys magnitude 10.3, contains one of the largest impact craters relative to body size in the solar system, Odysseus, a crater 450 kilometers across on a moon 1,062 kilometers in diameter. The impact that formed Odysseus nearly shattered Tethys. A slash of tectonic fracture Ithaca Chasma extends across 3/4 of the moon's circumference, possibly related to the same ancient impact. Enceladus magnitude 11.7, requiring larger telescopes and excellent conditions. Tiny, just 504 kilometers across and one of the most scientifically important objects in the solar system. Its south pole is geologically active in a way that no other icy moon in the outer solar system displays so dramatically. Geysers of water vapor erupt from the south polar terrain from fractures called tiger stripes and jet hundreds of kilometers into space. Cassini flew through these plumes and detected water, salt, organic molecules, molecular hydrogen, all the ingredients considered necessary for life as we understand it, present in the plumes erupting from a subglacial ocean kept liquid by tidal heating from Saturn's gravity. Something may live in Enceladus, The chemistry is there, the energy source is there, the liquid water is there. A tiny dot of magnitude 11.7 light, visible through a larger amateur telescope, is all of this. The moons on October 4th will be strung out in a line on either side of Saturn east and west along the ring plane, each at its own distance, each at its own stage in its orbit. They will look like a ruled line drawn through the rings, except that unlike the ring particles, each point of light is a distinct world with its own geological history, its own chemistry, its own story. Some will be closer to Saturn on October 4th, some will be farther, some will be in front of the planet's disk transiting, casting their tiny shadows on Saturn's cloud tops. Some will be behind the planet in occultation invisible until they emerge from behind the limb. Your planetarium app will tell you exactly where each moon is. On October 4th, use it. Look up Titan's position before you go outside. Know which side it will be on. Then find it in the telescope. The dot near Saturn, that specific dot at the predicted position, is a world with weather. That is worth knowing. There is one more feature of Saturn we need to address before we get to the practical experience of October 4th, a feature that no amount of pointing an amateur telescope at Saturn will show you, but that Cassini revealed and that fundamentally changed our understanding of what kind of world Saturn is. The hexagon. At Saturn's North Pole, there exists a persistent atmospheric structure unlike anything else known in the solar system, a hexagonal jet stream, approximately 32,000 kilometers across, large enough to contain 4 Earths rotating with the planet, maintaining its 6-sided shape for decades, and possibly for centuries. For all we know, despite being a fluid dynamic phenomenon, the hexagon was first photographed by the Voyager spacecraft in the 1980s. By the time Cassini arrived at Saturn in 2004, it was still there. By the time Cassini ended its mission in 2017, it was still there, still hexagonal, still rotating at the same angular velocity as the planet's deep interior. Nature does not make straight lines. The laws of fluid dynamics, which govern atmospheric circulation on all planets, produce curves and spirals and circles, the shapes that rotating fluids naturally adopt under the influence of Coriolis forces and pressure gradients. Every other persistent atmospheric feature on every gas planet we have ever observed is an oval, a circle, a spiral, or an irregular swirling structure. Saturn's North Pole has a hexagon. The mechanism is debated. Laboratory experiments have reproduced hexagonal patterns in rotating fluids under specific conditions involving the interaction of a polar vortex with surrounding jet streams. But the exact dynamics of Saturn's hexagon, why it persists so long, why it maintains such precisely defined corners, why the dimensions are what they are not fully understood. It appears to be a standing wave pattern, locked to Saturn's interior rotation by a mechanism whose details remain an active area of research. Inside the hexagon, at the very pole, sits a giant polar vortex, a swirling cyclone approximately 2,000 kilometers across, with wind speeds up to 500 kilometers per hour, with an ice so clear and defined that it looks almost artificial. A hurricane at the North Pole of Saturn, inside a geometric figure the size of 4 Earths. You will not see the hexagon on October 4th. It requires spacecraft imagery. But knowing it is there, at the North Pole of the golden sphere in your eyepiece, visible but not visible, like knowing that inside the amber-banded atmosphere there are metallic hydrogen layers, and radioactive decay, and internal heat, and a core of rock and metal is part of what changes how you see Saturn. After you know it, the innocent-looking golden sphere is a storm engine, a hexagon keeper, a world of internal violence visible only from spacecraft that dive close enough to see through the amber haze. The rings float, the hexagon spins, the geysers of Enceladus eject, Titan rains methane. And on October 4th, all of this is contained in a steady golden point of light rising in the southeast. Now let us talk about what you will actually see on October 4th. Not the philosophy, the experience. You go outside at roughly 9 p.m, the exact time depends on your latitude and longitude, but this is a reasonable starting point for most observers in the Northern Hemisphere. The sky is dark enough to have stars. Saturn is already well above the horizon, risen in the east at sunset and now climbing toward its highest point of the night, which will come near midnight. It is in the constellation Cetus. With your naked eye, you see a star. A golden star, brighter than most of the background stars, not twinkling the way stars do, but shining with the steady, unwavering light of a nearby world, steady because its disk is large enough that the atmospheric turbulence that causes stellar scintillation averages out across the disk instead of amplifying it. It is magnitude 0.3 on this night, brighter than it will be for the rest of the year, except in the days immediately surrounding the opposition date. You point a small telescope at it, a 60mm refractor at 50 times magnification, or a 100mm reflector, or a 70mm spotting scope on a steady tripod. The crosshairs center on the point and the optics resolve it. What you see will stop you. Not because it is the most technically perfect view, not because the resolution is extraordinary or the magnification is impressive, because what you see floating in the black circle of the eyepiece surrounded by the darkness of deep space is something that looks, at first glance, too perfect to be real. A small golden sphere, and around it, tilted at 7.5 degrees, extending outward on both sides like a hat brim or a halo or wings, the rings. They are not as wide open as the photographs. They are thinner than the textbook image, but they are there, unmistakably, undeniably, genuinely there. Not painted on, not a picture. A physical structure, 273,000 kilometers across, hanging in three-dimensional space, 1.26 billion kilometers from where you stand, coming to your eye as light that left Saturn 70 minutes ago. The light you are seeing left Saturn at approximately 7 p.m. Saturn, when the light entering your eye left it, was in mid-afternoon on its eastern hemisphere. Nearby within the field of view, within a few ring widths of the planet, a star-like point that is Titan, Saturn's largest moon, larger than the planet Mercury. The only moon in the solar system with a thick atmosphere, a moon with nitrogen rains and methane lakes and organic chemistry that scientists monitor with extraordinary interest for the clues it might provide about the chemistry of life's origins. It is a dot, an amber-coloured dot of light barely distinguishable from a background star. But knowing what that dot is, knowing it is a world larger than Mercury, a world with weather and seasons and a chemistry of staggering complexity, a world that the Huygens probe landed on in January 2005 and returned images of an orange landscape of rounded pebbles under a sky of thick organic haze. Knowing all of that changes the dot. The dot becomes a world. The light from the dot becomes a message from something real. And this is the core of what October 4th offers, that no ordinary night offers, the specific experience of looking at something you have seen photographs of 1,000 times, and discovering that the photographs were not enough. That the thing itself, seen in real time through your own optics, however modest, carries a reality that no image can fully convey. Let us talk about the Cassini division, because this is the detail that separates the people who have really seen Saturn from the people who have merely seen a picture. The Cassini division is a gap in the ring system, approximately 4,800 kilometers wide, between the bright A ring on the outside and the brighter B ring on the inside. It is named for Giovanni Cassini, the Italian-French astronomer who discovered it in 1675, the same Cassini who gave his name to the spacecraft that died in Saturn's atmosphere in 2017. Through a small telescope, the Cassini division appears as a dark line, a shadow-like groove cutting through the ring. It is the most obvious structural feature of the ring system visible to amateur telescopes. With a 60mm instrument at 50x magnification, you may glimpse it. With a 100mm at 100x, you should see it on a good night. With a 150mm or larger at 150x, it becomes prominent, a clear gap separating the outer A ring from the inner B ring, visible as a distinct dark band running parallel to the ring's inner and outer edges. The Cassini division is not actually empty. It contains material diffuse ring particles far less densely packed than the main rings. Its darkness comes from the relative sparseness of this material compared to the adjacent rings. It looks dark because it reflects less light, not because there is truly nothing there. The reason the division exists is resonance. A particle orbiting Saturn in the Cassini division would complete exactly 2 orbits for every 1 orbit of the Moon, Mimas. This 2-to-1 orbital resonance means that Mimas exerts a regular gravitational tug on particles at that location, always in the same direction at the same point in the orbit, that gradually pushes them out of the P division, leaving it relatively clear. Mimas is visible through a larger telescope on October 4th magnitude 12.8, very faint, very close to the planet, requiring at least a 200 mm aperture and excellent seeing. But its gravitational influence is written in the dark gap that a 60 mm instrument can show. Mimas sculpts Saturn's ring system from a distance of 185,000 kilometers. You can read its work through the simplest astronomical instrument capable of resolving the ring structure. This is what astronomy at its best does. It connects the thing, you can see a dark line in a ring, to the physics you understand orbital resonance, to the specific object responsible, a tiny moon in a chain of meaning that begins with a humble instrument and ends with a comprehensive understanding of gravitational dynamics that took centuries to develop. The Cassini division, on October 4th, is a lesson in how the solar system actually works, written in ice, hovering in the eyepiece, waiting to be read. Let us take a long excursion through the history of Saturn observation, because the 4th of October 2026 is not just an astronomical event. It is a moment in a 400-year story of human beings looking at a planet and slowly, incrementally, building an understanding of what they were seeing. We started with Galileo's bafflement in 1610. Let us continue from there. Christian Huygens, a Dutch mathematician and astronomer, designs a better telescope than Galileo had, a longer focal length, a cleaner lens. He points it at Saturn. Through the improved optics, the nature of the ears becomes clearer. He proposes that Saturn is surrounded by a flat ring, a single, flat, continuous structure, inclined to the ecliptic and entirely detached from the planet. This is the first correct description of the ring system. He publishes it, again in encoded form to establish priority, as the anagram ap lik igay, 3 lil, nowhere touching, inclined to the ecliptic, a thin, flat ring nowhere touching. He was right. Giovanni Domenico Cassini, the astronomer whose name would be given both to a division in the rings and to the spacecraft that discovered that division's true nature, is working at the Paris Observatory. He points his telescope at Saturn and sees something in the rings that Huygens had not reported. A gap. A dark division in what had appeared to be a single ring, separating it into two distinct components. The Cassini division, 4,800 kilometers wide, running all the way around the ring system. Saturn had not one ring, as Huygens had proposed, but at least two. William Herschel, the astronomer who discovered Uranus in 1781, the first new planet found in recorded history, is studying Saturn with an instrument far larger than anything his predecessors had used. He discovers Mimas and Enceladus, two of Saturn's inner moons, using a 1-2 meter reflector telescope of his own construction. He discovers them during a ring plane crossing. With the rings edge on, the moons that normally hide in the ring system's glare suddenly become visible. The disappearance of the rings reveals the moons. This is the pattern. Every time the rings go edge on, something new appears. Every time the view is stripped to its essentials, the things normally hidden by the most beautiful part of the view emerge. Johann Encke, the astronomer who calculated the orbit of the comet that bears his name, discovers another gap in Saturn's A-ring. The Encke division, much narrower than the Cassini division, 325 kilometers wide. The ring system has at least three components now: an outer A-ring, a middle B-ring, a dark Cassini division between them, and the Encke gap in the outer A-ring. William Crunch Bond at Harvard discovers Hyperion, Saturn's chaotically tumbling irregular moon, during the same ring plane crossing period that reveals objects normally hidden in the ring glare. Again, the rings disappearing unmasks something new. James Keeler at the Allegheny Observatory performs the critical spectroscopic measurement that settles the question of whether the rings rotate as a solid disk or as individual orbiting particles. He measures the Doppler shift of the reflected sunlight from different parts of the rings. If the rings were solid, the outer edge would be moving faster than the inner edge. If they were individual particles in orbit, the inner particles would be moving faster than the outer particles' Keplerian rotation. The inner ring particles are moving faster. The rings are not solid, they are an ocean of ice in orbit. The solid disk model, attractive for its visual elegance, was wrong. The true picture, billions of individual particles, each following its own orbit, creating the appearance of a solid structure through sheer density and mutual proximity, was more complex and more astonishing than the simpler model. 1,966 and 1,979 ring plane crossings. Each one reveals new moons, Epimetheus and Janus, in 1966, discovered because the edge-on rings unmasked their faint light. In 1980 and 1981, Voyager 1 and Voyager 2 fly through the Saturnian system and return the first close-up images. The ring system, previously described as 3 or 4 rings, turns out to be thousands of individual ringlets and gaps, each one with its own density and composition. The whole system, a gravitationally complex tapestry of resonances and shepherd moons and density waves. The simple picture that Huygens described in 1655, a thin, flat ring nowhere touching, was correct in its broad outlines and incomplete in every detail. This is the pattern of Saturn's observational history. Each generation sees more clearly than the previous one. Each generation believes it has understood what it is looking at, and each generation is surprised by what the next level of clarity reveals. Galileo thought there were ears. Huygens found a ring. Cassini found a gap. Encke found another. Keeler found the particles. Voyager found thousands of rings. Cassini found the geysers of Enceladus, the subsurface ocean, the complex organic chemistry of Titan's atmosphere, the age of the rings, the ring rain, the hexagon. What does the next generation find? We do not know yet. But on the 4th of October 2026, you are standing in the continuous line of descent from Galileo, the chain of observers who have pointed an instrument at the Golden Wanderer and tried to understand what they were seeing. Your small telescope, or your naked eye, or even just the knowledge you carry from this video, all of it is part of that chain. All of it is participation in a 400-year project of accumulating understanding. You are not a passive observer. You are the continuation of Galileo's observation, conducted with the advantage of everything that has been learned since 1610. Consider what it would have meant to Galileo to have access to what you have right now. He had a 30-power telescope, and the naked eye, and the accumulated astronomical knowledge of 2,000 years of observation, the entirety of human astronomy, prior to 1610. With these tools he found the ears and was baffled when they disappeared. You have access to the complete explanation. You know the rings are real, you know why they appear and disappear. You know how thin they are, 10 meters in some places, 1 kilometer at most, and why that thinness makes them invisible when edge-on. You know what the rings are made of: water ice, primarily, with rock and organic material mixed in. You know where the rings came from, probably a moon destroyed by tidal forces somewhere between 10 million and a few hundred million years ago. You know they are dying, losing mass to ring rain at tens of thousands of tons per day, leaving 100 to 300 million years before they are gone. You know about the Cassini division and why it exists, the orbital resonance with Mimas that sweeps material from that location. You know about Enceladus and its geysers. You know about the hexagon. You know about the Great White Spot. You know about Titan's methane lakes and organic chemistry, and the Huygens probe that descended through its haze and photographed the ground. You know about Cassini the spacecraft, its 13-year mission, its grand finale, its deliberate plunge. You have the complete knowledge. Galileo had the original view. What October 4th offers is both the original view, the first-hand visual experience of the thing itself, and the complete knowledge, the layered understanding of what you are seeing that centuries of science have assembled. This combination, direct observation plus complete context, is rarer than you might think. Most of what we know about the universe is known only through indirect measurement, through data analysis, through instruments far too sensitive to look through an eyepiece. Most of the universe's wonders are not accessible to direct observation with modest equipment. Saturn is accessible. On October 4th, with any telescope at all, you can see it. Not the data about it, not the proxy measurement of it. It. The rings and the disk and the moons, in real time, with photons that left the planet 70 minutes ago arriving at the retina of your eye. Galileo had the direct observation without the context. You can have both. October 4th is the night that combination is available in its best form of the year. Do not let it pass. Let us also talk about the ring system's structure in more detail, because the rings are the reason you are watching October 4th. and understanding their architecture transforms what a flat-looking ring in a telescope reveals. The ring system, from inside to outside, consists of several named components. The innermost is the D ring, a very faint diffuse ring inside the orbit of the C ring, discovered by Voyager, impossible to see with amateur telescopes. The C ring, the crepe ring, is the innermost ring visible in amateur telescopes, though it requires at least a 150 mm aperture and excellent seeing. It appears as a faint, partially transparent band inside the bright B ring, its transparency allowing Saturn's disk to shine dimly through it. The B ring is the most massive and most reflective. It is what gives Saturn's ring system its brilliant white appearance in photographs. The B ring's optical depth, the measure of how much light it blocks, is so high in some regions that it is essentially opaque. Light cannot penetrate it. In the most densely packed regions, the ring is so thick with particles that the far side of the ring is completely hidden. The Cassini division is the large gap between the B ring and the A ring. Not empty, but far less dense than the adjacent rings. Its relative darkness comes from the low density of its material, compared to the brilliance of the rings flanking it. The A ring is the next major component, slightly less bright than the B ring, contains the Encke gap, a narrow clearing caused by the shepherd moon Pan, which orbits within the gap and keeps it clear. Pan is tiny, 28 kilometers across, and was discovered specifically because of the Encke gap's existence. Something had to be clearing it. The F ring, outside the A ring, is a narrow, kinked, twisted ring, the most dynamic and visually complex of all the rings. Its structure maintained and deformed by the shepherd moons Prometheus and Pandora, which orbit just inside and outside it respectively. Their gravitational influence braids the F ring into the knotted, multi-stranded structure visible in Cassini's close-up images. Beyond the F ring lie the sparse G and E rings, extremely faint, diffuse, essentially invisible to amateur observers. The E ring is remarkable because it is actively maintained by the geysers of Enceladus. The material ejected from Enceladus's south pole plume spreads out to form the E ring, making Enceladus both a source of ring material and an orbiting object within a ring it is generating. The entire ring system, D through E, spans over 480,000 kilometers from the inner D ring to the outer E ring, a span comparable to 37.7 times the diameter of Earth. If you laid the ring system flat on the face of the Sun, it would extend from the Sun's center to roughly 35% of the way to its edge. It is, in area, one of the largest structures in the solar system, and it is made of ice-water ice, the same substance that forms snowflakes on Earth, the same substance that fills the world's oceans, the same substance that covers the poles. Billions of trillions of pieces of water ice, orbiting a planet 1.3 billion kilometers away, thin as a human hair relative to their width, illuminated by a sun whose rays take 70 minutes to reach them, and visible from your backyard through a $100 telescope. On October 4th, through your telescope, you will see the B ring, the Cassini division, and the A ring. Possibly the C ring, if conditions are good and your aperture is sufficient. That is 3 of the named ring components out of many. The architecture visible to you is the central, most spectacular part of a structure that extends far beyond what your telescope shows. What you see is the best part, the innermost, most massive, most reflective, most structured part, the rings in their densest, most defined form. The architecture that inspired 4 centuries of astronomers to look again and look closer and ask the questions that eventually produced the understanding of what you are looking at. There is something else happening on October 4th that almost nobody is talking about. Something that, once you know it, makes the opposition feel less like a casual observing event and more like a specific milestone in a long story. The rings that are returning, the rings tilted at 7.5 degrees, becoming more open as each month passes, are returning from the south. After the March 2025 ring plane crossing, as Saturn's southern hemisphere began to tilt toward Earth, we are now looking at the ring system from below, from beneath the ring plane, the south face of the rings. This matters because for the previous 8 years from the time the north face was last facing us at maximum tilt in 2017 until the ring plane crossing in 2025, we were seeing the north face of the rings. Cassini, in its time at Saturn, saw the rings from above and below, from both faces. but ground-based observers have been seeing the north face of the ring system since 2009. On the 4th of October 2026, you are seeing the south face. The south face of Saturn's ring system has been angled away from Earth since 2009, 17 years since any ground-based observer had a view of this face of the rings at any useful tilt angle. On October 4th, it begins its slow return to maximum tilt, reaching approximately 27 degrees south face tilt in 2032. By 2032, when the rings are at their maximum display, it will be the south pole of Saturn tilted most toward Earth, the southern polar vortex, the southern hemisphere cloud bands, the southern face of the ring system, the southern hemisphere of Titan. The Saturn of the 2030s will be a different Saturn than the Saturn of the 2010s, seen from a different angle, revealing different features in the cloud bands, showing different illumination geometry on the rings and moons. October 4th is the first good look at this new geometry, the first opposition at which the south face of the rings has been visible at a useful angle since the beginning of this new cycle. The first night, after 17 years, that you are looking at Saturn from below the ring plane. Now let us make October 4th specific. Let us make it practical. Let us transform the astronomy into an experience, because experience is what this date is actually about. You do not need a large telescope. This is the first and most important thing to say. The first time you see Saturn's rings through any telescope is one of the most reliable sources of genuine, immediate, inarguable wonder available to human beings without specialized training. Astronomy professionals, people who have spent careers looking at astronomical objects through instruments of extraordinary power, continue to pause when they swing a telescope to Saturn and actually look at what they have been studying computationally. The experience and the knowledge are different things. The experience at Saturn is almost always more powerful. Minimum equipment: a 60mm refractor or a 90mm reflector with an eyepiece giving at least 50x magnification. This is an instrument available for under $100. Through it, you will see the rings as a distinct structure extending from the planet's disk. At 7.5 degrees of tilt, they are there, visible, recognizable, genuinely beautiful. Better equipment: a 100mm to 150mm aperture telescope at 100 to 150x magnification on a night of steady atmospheric seeing. Through this, you will see the Cassini division. You will see the disk of Saturn showing subtle cloud banding. You will see Titan as a clear, distinct point. You may see one or two additional moons on good nights. Optimal equipment: a 200mm or larger aperture, a 6-inch to 8-inch Dobsonian reflector, available for $300 to $500, is the best dollar per inch of aperture value in amateur astronomy at 150 to 250x on an excellent seeing night. Through this, the ring structure becomes complex. The A ring, B ring, and the dark Cassini division between them are distinct. The C ring, the faint, dusky inner ring, sometimes called the creep ring, may be visible as a transparent gauze between the B ring and the planet's limb. Multiple moons string out from either side of the planet. The cloud bands show color and structure. The shadow of the rings on the planet, a dark curve on the globe, is visible. The most important instrument is not the telescope, it is patience. Saturn is a planet that rewards waiting. The atmosphere is constantly moving, and the turbulence it produces creates an effect called seeing the image of Saturn blurring and sharpening repeatedly as packets of air of different temperatures pass through the optical path. On a night of poor seeing, even the finest telescope shows a blurry, boiling image that reveals very little detail. On a night of excellent seeing, even a modest telescope shows remarkable clarity. The technique for dealing with this: observe for time. Point the telescope at Saturn at 9 p.m. and look at it repeatedly, every 30 minutes or so, throughout the night. Atmospheric seeing improves as the night cools and turbulence decreases. The best views of Saturn typically come between 11 p.m. and 2 a.m., when the atmosphere has had time to settle, and when Saturn is highest above the horizon, minimizing the length of atmosphere between you and the planet. And go to a dark location if you can. Not because Saturn needs a dark sky the way faint galaxies do. Saturn is bright enough to show its rings from the middle of a city. But because the dark sky around Saturn, seen from a genuinely dark location, changes the experience. The planet surrounded by the black of deep space, not the grey-purple light pollution of a suburb, has a visual impact that is not just aesthetic but psychological. It looks farther away. It looks more isolated. It looks, as it actually is, like a world hanging in deep space at a distance that light takes more than an hour to cross. Get away from the city lights. Go outside after dark. Find the golden star in the southeast. And if the weather is bad on October 4th, if clouds cover the sky, if you live somewhere with persistent autumn overcast, if the stars are simply not accessible that night, the next night will work. And the night after that, Saturn's opposition period extends for weeks on either side of the exact date, September 24th through the 9th. Of October 2026 are the peak brightness period. Any clear night in October, or indeed any clear night through the end of November, will show you the rings at a tilt worth seeing. The specific night of October 4th is the best night of the year. It is the night to make the effort, to prioritize, to choose the telescope over the television. But the window is months, not hours. If October 4th is clouded out, October 11th is nearly as good. October 18th is still excellent. November nights are somewhat later in timing and slightly further from opposition, but still show the rings returning at roughly the same tilt. Do not let a single cloudy night be the reason you miss the beginning of the rings' return. The rings will be there. The only variable is whether you look, and if you look on October 4th, or any night close to it, with even the most basic instrument, or even just with your naked eye and the knowledge this video has given you, you will be participating in the same activity that Galileo was doing in 1610 when he noted the planet's unusual shape, that Huygens was doing in 1655 when he decoded the ears as a ring, that Cassini was doing in 1675 when he found the division. The activity of looking at Saturn and paying attention to what you see. Point something at it. Let us be more specific about what to look for through the eyepiece, because the difference between someone who sees Saturn and understands what they're seeing and someone who just sees a pretty image is the knowledge of where to look and what the specific features mean. The ring shadow on the globe. On October 4th, Saturn is 1 day past opposition. 1 day past the moment when Earth is precisely between Saturn and the Sunday. This means the Sun-Saturn-Earth geometry is very slightly off from perfect alignment, and this slight offset produces a visible shadow. The ring system, extending outward from Saturn's equatorial plane, blocks sunlight from reaching part of Saturn's disk. The shadow appears as a dark curved band on Saturn's northern hemisphere, running parallel to the ring plane. It is the visual proof that the rings float in three-dimensional space above the planet's cloud tops. You can see it in a 100mm telescope under good conditions. In a 150mm or larger instrument, it is prominent. This is the three-dimensional nature of the system, visible in a shadow. The planet's shadow on the rings. The reverse geometry. Saturn's globe blocks some of the sunlight that would otherwise illuminate the inner rings, casting a shadow on the ring system. This shadow appears on the rings on the same side as the ring shadow on the globe. Both shadows fall on the northern side of the ring system, because we are looking slightly from the south at 7.5 degrees ring. Tilt. The shadow creates a darkening on part of the inner ring system that further reinforces the three-dimensional structure of what you are seeing. Ring photographs taken at opposition show this clearly. Through a good amateur telescope on a steady night it is detectable. The Cassini division's width. The division appears as a dark line. At 7.5 degrees ring tilt, the rings are relatively thin in apparent extent, which means the Cassini division appears narrower than it will in subsequent years. But it should be detectable in a 100mm aperture at 100x on a good night. As the ring tilt increases in subsequent years, the apparent width of the Cassini division will increase, making it progressively easier to see. October 4th is the beginning of this progressive revelation. The colour of the rings versus the globe. Saturn's disk has a warm amber-yellow colour. The rings have a different colour, whiter, icier, cooler. The B ring in particular appears quite bright and somewhat blue-white compared to the planet's disk, reflecting the predominantly water-ice composition of the ring particles. This colour difference is subtle but visible in larger telescopes. The gap between the rings and the globe. The rings do not touch the planet. The innermost visible ring, the inner edge of the C ring, orbits at a distance of roughly 74,000 kilometers above Saturn's cloud tops. Through a telescope at 100x or higher magnification, this gap between the planet's disk and the innermost ring edge is visible as a dark space, a region of sky between the planet and the ring where there is genuinely no ring material. The rings float above the planet. You can see the space between them. Titan's colour. Under high magnification in a steady atmosphere, Titan shows a faint amber-orange colour distinguishable from the white-blue colouring of the more distant stars in the same field of view. This colour comes from the same organic photochemical haze that makes Titan's atmosphere opaque in visible wavelengths. You are seeing the atmospheric colour of another world from 1.3 billion kilometres away. There is a community of people who watch Saturn every clear night, from September through January, the Saturn opposition season, in the way that some people follow sports teams or track stock prices. They note the ring tilt every month. They photograph the cloud band structure. They log Titan's position. They compare 1 year's view to the previous year's view. They watch, in patient real time, the ring system's slow progression from edge on to open. This community is not professional astronomers. It is amateurs people with small to medium telescopes on garden tables or apartment balconies or suburban driveways, contributing to a long tradition of amateur planetary observation that has produced discoveries. The Great White Spot has historically been found by amateur observers before professional astronomers pointed large telescopes at it, and has generated a continuous record of Saturn's appearance across more than a century of systematic photography. October 4th is the night to join this community. Not by buying expensive equipment or subscribing to any organisation, just by going outside, pointing something at the sky, and deciding that the golden star in the southeast is worth understanding. The understanding comes from watching it repeatedly. One night's observation is a photograph. A year's observation is a data set. A decade's observation is a relationship with an object, a knowledge of its behaviour and variation and character that no single night provides. On October 4th, the relationship begins. Before we arrive at the final thought about October 4th, there is one more element of Saturn that deserves its own section, not because it will be visible on October 4th in any direct way, but because knowing about it changes what the banded yellow sphere in your eyepiece represents. The storms. Saturn's atmosphere is not placid. The visible surface, the banded clouds of ammonia ice and ammonium hydrosulfide, is the quiet outer face of an interior that is periodically and dramatically violent. And the most dramatic expression of that interior violence is a phenomenon that has been observed approximately once every Saturnian year, approximately every 29.5 Earth years since systematic observations began. It is called the Great White Spot. Unlike Jupiter's Great Red Spot, a centuries-old anticyclonic storm of modest violence, Saturn's Great White Spot is not a permanent feature. It is a periodic eruption, a storm that breaks through from the depths of Saturn's atmosphere with the kind of violence that only a planet with enormous gravitational and internal thermal energy reserves can produce. The mechanics work like this. Deep in Saturn's atmosphere, far below the visible cloud tops, there is a layer rich in water vapour. Normally, this layer is sealed beneath the stable, stratified atmosphere above it. The ammonia clouds at the visible surface act like a lid. The water-rich layer smoulders. Then, roughly every Saturnian year, every 29.5 Earth years, triggered by Saturn's northern hemisphere summer solstice, the convective instability that has been building in the water layer overcomes the stable stratification above it. A column of warm, water-rich air erupts upward through the ammonia cloud layer. It breaks through to the visible surface like a geyser punching through ice, forming a brilliant white cloud head that can be tens of thousands of kilometers across within days of its formation. The erupting column keeps rising. It overshoots the cloud layer and bursts into Saturn's stratosphere. The spreading material from the storm head wraps around the planet, encircling the entire circumference circumnavigating Saturn, which is 380,000 kilometers around the equator within weeks. A storm that wraps entirely around a planet larger than 1,000 Earths. A thunderstorm that circles the equator of a gas giant. A weather event of such violence that the lightning within it, detected by Cassini's radio instruments, produces radio bursts 10,000 times more powerful than the most powerful lightning on Earth. The most recent great white spot was observed in 2010 and 2011. Cassini was there. It documented the storm in extraordinary detail, the initial eruption in December 2010, the rapid spread, the eventual encirclement of the planet, the interaction of the storm head with the tail of the storm system circling behind it, the collision of the two fronts, the disruption of the storm structure after the circulation reconnected. Cassini's radio instruments detected thousands of lightning strikes per day during the storm's peak activity. By the Cassini mission's timeline, the next great white spot should occur sometime in the 2030s, roughly 29 years after 2010. The exact date cannot be predicted. The trigger Northern Hemisphere summer solstice occurs on a predictable schedule. Saturn's northern solstice was in 2017, but the convective instability that determines when the storm actually erupts introduces uncertainty. It could be 2037, it could be 2039, it could be 2041, but it is coming. On the 4th of October 2026, you are looking at a planet that is building toward its next great white spot. The convective instability is accumulating in Saturn's deep atmosphere. The water-rich layer below the visible clouds is slowly, inexorably, charging up toward the eruption that will eventually break through. It may be 10 years away, it may be 15. But when it erupts, when the next great white spot appears in the atmosphere of the golden planet in your eyepiece, it will be visible to amateur telescopes. A brilliant white cloud expanding, spreading, eventually encircling the planet. A storm visible from 1.3 billion kilometers away through a $100 instrument. Look for it in the 2030s. Look for it by pointing the same telescope at the same golden point of light in the southern sky. Watch for a change in the banded pattern. Watch for a white brightening in the northern hemisphere. If you see it, you are seeing one of the most violent weather events in the solar system. Let us also talk about what the rings will look like in the years following October 4th. Because October 4th is not the destination. It is the beginning of a viewing cycle that will culminate in 2032, and understanding where you are in that cycle makes the October 4th view richer and the subsequent years more rewarding. The ring tilt on the 4th of October, 2026, 7.5 degrees. Every opposition from 2026 through 2032, the rings will be slightly more open, more tilted toward Earth, more of the ring surface visible, more of the ring structure revealed. Opposition 2, 02, 7, October 18. Ring tilt approximately 11 degrees, markedly more open than 2026. The Cassini division, easier to see. The C ring more accessible. Opposition 2, 02, 8 October 30, approximately 15 degrees. Approaching the range where the full geometry of the ring system begins to display itself. The shadows, the color variations, the full length of the ring plane visible. Opposition 2, 029, November 12, approximately 18 degrees. This is approaching spectacular. Opposition 2, 03, 0 November 25, approximately 21 degrees, genuinely stunning. Every telescope at every price point will show the rings in their best form since 2017. Opposition 2, 03, 1 December 8, approximately 24 degrees, outstanding. The greatest detail of the ring system visible in small telescopes since 2017. Opposition 2032, maximum tilt, 27 degrees, the best Saturn viewing since 2017. The best until approximately 2046, when the next cycle peaks. The years from 2026 to 2032 are a continuously improving Saturn show, every year better than the last. Every year's opposition showing more open rings, more ring surface, more detail. The 4th of October 2026 is the first chapter of a 6-year story of increasing splendor. If you start watching Saturn on the 4th of October 2026, and continue watching it every October, every year, for the same duration, with the same telescope, noting how the rings look, by 2032, you will have a personally witnessed record of the ring system returning from edge-on to maximum tilt. You will have seen, with your own eyes, the same transformation that Galileo experienced across a different decade. Galileo watched the ears appear, disappear, and reappear over several years. You can watch the rings emerge from nearly edge-on to full, glorious tilt. You just need to start on October 4th. There is one final thing about the ring plane crossing of March 2025 that has not been mentioned yet, and it is perhaps the most poignant. When the rings went edge-on in November 2025, the second crossing, the more observable one, and Saturn appeared as a bare yellow sphere in telescopes for the first and last time in 16 years, something else happened that most observers were not prepared for. The moons became the show. With the rings nearly invisible, the attention of anyone pointing a telescope at Saturn shifted to the moons. Titan, usually visible but visually dominated by the ring system, suddenly became the most prominent feature. Its amber point of light, extending from the bare disk of Saturn on a long elliptical orbit, was more visually interesting than it had been in years. The other inner moons Rhea, Dione, Tethys became visible without the ring glare competing for attention. And because the moons all orbit in the ring plane, they formed a perfectly linear array extending from both sides of the bare disk, a ruled line of worlds, each one distinct, each one a different distance, each one a different magnitude. This is what Herschel saw in 1789 when he found Mimas and Enceladus. He was looking at Saturn without its rings, and the moons that are normally hidden in the ring glare emerged from hiding. Stripped of its rings, Saturn is a different observing target, and a surprisingly rewarding one. On the 4th of October 2026, the rings will be back. They will take your eye immediately. They will be the spectacle. But inside your field of view, strung out on either side, the moons are still there, the same moons that were there in November 2025 when the rings were gone. The same moons that Herschel found by looking at a ringless Saturn in 1789. They do not disappear when the rings return. They become harder to notice. On October 4th, once the rings have stopped your breath, look for the moons, identify Titan, note its position relative to the planet. Know which side of the planet it will be on by checking your planetarium software before you go outside. Find the smaller moons if your telescope and the seeing allow. Understand that each pinpoint of light is a world, and that the world of Saturn is not the rings but the entire system rings, moons, planet, atmosphere together. You are looking at a planetary system, not a planet, a world. Let us make the specific case for why the 4th of October 2026 is different in kind, not just degree from an ordinary Saturn opposition. Consider what the average person who has never deliberately observed Saturn knows about it. They know, if they know anything, that it has rings. They have seen a photograph of the rings, probably a Hubble or Cassini image, one of the canonical beautiful images that circulate endlessly as the visual definition of what Saturn is. The rings are tilted, wide open, clearly defined, strikingly beautiful. That photograph was taken when the rings were open, probably 2017 or 2021, or some other year when the tilt was substantial. It was taken by an instrument far more powerful than any amateur telescope. It was processed and enhanced to reveal the ring structure in its most photogenic form. It is not wrong, the rings look like that. But that photograph does not tell you that the rings nearly disappeared a year ago. It does not tell you that the view you are looking at now, through your own telescope, is the first opposition view of returning rings, the beginning of a 6-year progression toward maximum tilt. It does not tell you that the rings are 100 million years old at most, that they are dying, that Cassini found this out and told us before it chose to burn up in Saturn's atmosphere. The photograph shows you the subject matter. October 4th gives you the story. And the story is what changes how you see everything afterward. Not just Saturn, everything. Once you know that the most beautiful thing visible in the night sky is temporary, that it formed after the dinosaurs, that it is dissolving into the planet it surrounds, that in 100 million years there will be nothing left of it, you cannot unsee that knowledge. Every subsequent glance at the golden point of light in the southern sky carries the weight of that knowledge. Every telescope view of the rings carries the awareness that you are looking at something that did not always exist and will not always exist. You are seeing it in the window. Once you know that a spacecraft chose to die to preserve the purity of the moons, it found that 43 years of engineering and 13 years of science ended in a deliberate plunge into a planetary atmosphere, Every image of Saturn carries the knowledge of Cassini's ghost in its clouds. Once you know that the rings went edge-on last year, that Galileo saw them disappear in 1612 and wrote that he did not know what to say, that you are now watching them come back. Every future view of the ring tilt carries the awareness of the cycle. The awareness that what you are seeing is not static but moving, not permanent but processual, not a snapshot but a frame in a story that takes 30 years to tell. October 4th changes how you see Saturn, because it is the specific night when all of this knowledge converges with direct observation. The night when the context and the experience meet. The night when the golden star becomes, definitively, the ringed planet returning, impermanent, historic, and yours to see while it is here. There is one more comparison worth making before we reach the final words. 40 years from now, in 2065 or 2066, Saturn will be approaching its next ring plane crossing. The rings will be going edge-on again. Some of the people watching that event will have been watching Saturn since 2026. They will have seen the rings at 7.5 degrees on October 4th. They will have watched them open to 27 degrees by 2032. They will have watched them narrow again toward edge-on. In 2038, the next ring plane crossing, and then open again. They will have seen, across 40 years of direct observation, the complete half-cycle of Saturn's ring display, from edge-on, through maximum tilt, back toward edge-on. This is a gift that is available to anyone who starts watching on the 4th of October, 2026, and continues watching. Not a professional achievement, not a specialized skill. Just the patient accumulation of annual observations of the same object across decades. The complete half-cycle, starting now. Galileo's bafflement makes complete sense when you consider that he did not have the benefit of the full cycle. He saw the ears in 1610. He saw them disappear in 1612. He did not live to see them return. He died in 1642, and the rings reappeared clearly in the mid-1610s and subsequent years. He never understood what he was looking at because he did not have enough time. You have enough time. The cycle is 30 years. You can watch it. October 4th is the starting line. The last thing to say about October 4th is something that has nothing to do with telescopes or ring tilts or Cassini's legacy. It has to do with scale. You are standing on a planet. This planet is one of 8 in a system orbiting a star. The star is the Sunday. The system is 4.5 billion years old. Saturn, the 6th planet, has been orbiting this star for all 4.5 billion years of the system's existence. In those 4.5 billion years, it has completed approximately 153 million orbits. And in that entire time, across all 153 million orbits, the rings have been present for perhaps 10% of it. Less. You are alive during that 10%. The probability of this, if you were choosing a random moment in the solar system's history to exist, is roughly 1 in 10. Not high odds, but not impossible, and not evenly distributed. The period during which a technological civilization capable of building telescopes can exist is itself constrained to a much narrower slice of solar system history. We exist when we exist because of a long chain of evolutionary, geological, and cosmological contingencies, many of which are effectively unique. We are here now. The rings are here now. They were not always here. They will not always be here. The coincidence of our existence and their existence is not guaranteed to recur. This is not meant to induce existential dread. It is meant to induce the opposite, the specific, grounded, practical appreciation that what you are looking at on October 4th is not an eternal fixture of the sky, but a temporary feature young, beautiful, and impermanent that you have been given the chance to see. Look at it with that knowledge. Look at it knowing about Galileo's bafflement and Huygens' revelation, and Cassini's discovery of the division and the spacecraft that bore his name and chose to die rather than contaminate the moons it found. Look at it knowing that the rings nearly vanished 18 months ago and are now returning. Look at it knowing that by 2032 the rings will be more open than they have been since 2017. Look at it knowing that in 100 million years they will be gone. Look at it knowing that Cassini is there, mixed with Saturn's atmosphere. The atoms that were once spacecraft are now cloud. The instrument that changed our understanding is now part of the object it changed our understanding of. Then look up from the eyepiece. Look at the steady golden star with your naked eye. Think about what that means. For 13 years, Cassini orbited Saturn and photographed it and measured it and discovered within it things that no one had previously known. It found the geysers of Enceladus. It found the age of the rings. It found the hexagon spinning at the North Pole. It found the ring rain that is slowly dissolving the rings into the planet. It found all of this and sent the data home across 1.3 billion kilometers of vacuum, photon by photon, at a rate so slow by modern digital standards that the entire Cassini science data archive could be transferred over a decent home internet connection in about 3 days. And then, having found all of this, the spacecraft was directed into the atmosphere and destroyed. Not because the mission had failed, because it had succeeded so well that its operators were unwilling to risk contaminating what it had found. The engineers and scientists who built Cassini and ran its mission for 20 years from the 1997 launch through the 2017 end did not know, when they began, what they would find at Saturn. They built the best instrument they could with the technology of the early 1990s, aimed it at the most visually spectacular planet in the solar system, and launched it into the dark. They did not know about the Enceladus geysers until Cassini found them. They did not know about the ring age until Cassini measured it. They found out by going. This is what the 15th of September 2017 plunge into Saturn's atmosphere was protecting. Not just Enceladus and Titan from earthly contamination, though that was the immediate stated reason. The entire scientific legacy of those 20 years, the integrity of the discovery, the certainty that what was found in an uncontaminated system. Cassini's atoms are in Saturn's atmosphere. When you look at Saturn on October 4th, you are looking at the planet that consumed Cassini. You are looking at the same disk, the same atmosphere, the same cloud bands that the spacecraft entered for the last time in 2017. The specific molecules of Cassini's structure, the aluminum and titanium, and electronic components and scientific instruments are somewhere in those clouds, mixed and dispersed and carried by Saturn's circulation patterns, undetectable but present. Look at it knowing this. The object in your eyepiece is not just a planet with rings. It is a monument. That is the object. That is what all of this is about. That tiny, perfect point of light carrying the rings and the moons and the storms and the history and the future of one of the most beautiful things in the solar system. And it carries something else that most people never think to carry when they look at it. It carries the knowledge that the view is changing. That last year was different. That next year will be different. That in 2032 it will be different still, and that by then the rings will be more spectacular than they have been in your adult lifetime. The night sky appears static. The stars appear fixed. The planets appear to be what they appear to be every night, reliably, reassuringly the same. But they are not the same. The ring system of Saturn is not the same as it was in 2017. It is not the same as it was in 2024. It will not be the same in 2030. Every year the tilt changes. Every decade the perspective changes. Every 29 years the cycle completes and begins again. The sky is not a photograph. It is a film, running in slow motion at a speed that requires decades to appreciate. October 4th is the night you begin to appreciate it. The Saturn you will see on October 4th is specifically the Saturn of the 4th of October, 2026, tilted at 7.5 degrees, returning from its near disappearance, crossing the sky at its brightest point of the year, at its closest point to Earth, visible all night from any location on Earth that is not overcast. It will never be exactly this Saturn again. Next year it will be slightly different. The year after, more different still. This is the one night, this specific configuration of Earth and Sun and Saturn and ring tilt and orbital geometry that will be exactly what it will be on the 4th of October, 2026. And then it will be gone, and the next configuration will take its place. Go outside. The rings are coming back. It is there. It is visible tonight. On October 4th it will be at its best. You will never see them the same way again. That is the object. That is what all of this is about. That tiny, perfect point of light carrying the rings and the moons and the storms and the history and the future of one of the most beautiful things in the solar system. It is there. It is visible tonight. On October 4th, it will be at its best. The rings are coming back, and you will never see them the same way again. And you will never see them the same way again. Here is what that means practically. After October 4th, every time you see the word Saturn in a headline, in a documentary, in a classroom, in a museum exhibit, you will have a frame of reference that most people do not have. You will know that the rings are young. You will know they are dying. You will know that in March 2025 they nearly vanished, and you are now watching them return. You will know about the ring plane crossing that Galileo observed in 1612 and couldn't explain. You will know that a spacecraft called Cassini spent 13 years there and then chose to die in the planet's atmosphere rather than contaminate the moons it found. You will know when you look at a photograph of Saturn that the tilt of the rings in the photograph tells you what year the photograph was taken, whether the north or south face is showing, how open the rings appear, where in the 2-9-year cycle the image represents. You'll know that the golden steady star in the southern sky every autumn evening is the most beautiful thing visible from Earth with any modest instrument, that it was there before humans existed and will be there long after this specific version of human civilization is gone, and that the rings surrounding it, the feature that defines it, the feature that stops every first-time telescope viewer in their tracks, are a temporary thing, a grace note, a cosmological accident of timing that places us in exactly the century when the rings are there. This is why October 4th changes how you see Saturn forever. Not because the view changes the rings will be 7.5 degrees regardless of whether you understand them. Not because Saturn changes it will be at 8.43 AU regardless of whether anyone looks. Because you do. Saturn is there, every clear autumn evening. It rises in the east at sunset on October 4th. It crosses the meridian near midnight. It sets in the west at dawn. It is the brightest star-like object in the southeastern sky on that night. Unmistakable once you know where to look and what a non-twinkling point of steady golden light means. Every cloud band, every ring, every moon, every atom of Cassini dissolved into its atmosphere, every gram of ring material slowly raining into its clouds, every degree of ring tilt slowly increasing toward 2032. All of it is there. All of it is in that point of light. Go find it. You have been told what you are looking at. Now look. The rings are coming back. October 4th is waiting. The rings will be 7.5 degrees open and returning. Go look.